reviewing for the first quiz in chapter 6. So we are looking at solving exponential equations for these first 4. When you have an exponential equation, to solve problems like this, we need to have both sides of the equation have a common base to the exponent. So I'm going to look at this one and look at the 8 right here and think about how can I rewrite 8 to see if as 8 as a power of 2. So I know that 8 is the same as 2 to the third. So I'm going to replace that 8 with 2 to the third. And that will give me a 2 as a base on both sides of this equation. So I have 2 to the 2x plus 2. And then over here I have 2 to the third to the 2x plus 3. Now that I have common base, I can basically cancel out this part of the equation. And then I am going to be left with 2x plus 2 on the left side. And over on the right side, I'm going to be left with 3 times 2x plus 3. And a common mistake in this problem would be to forget about the distribution on the right side. So I have 3 times the quantity 2x plus 3. So remembering to distribute, this is going to give me 6x. And then 3 times the 3 is going to be 9. So now I am going to work to just solve this equation for x. Right? I'm going to subtract the 2x over, so I'll have 4x plus 9 equals 2. And then I can subtract the 9 over to the left side of the equation. So that will give me 4x equals negative 7. So after I divide out the 4 from both sides, I'm going to have x equals a negative 7/4. So leaving that in improper fraction form would be just fine there. So for number 2, we're going to do the same thing, right? I can replace the 9 in 9 to the 2x plus 6 power with 3 squared. So that gives me 2x plus 6 still up here on the top. And now that I have a common base of 3, right, I can bring those exponent parts down. So that will give me 5x equals 2 times the 2x plus 6. And now I could work on this distribute step as I bring it down. So that would be 4x plus 12. Okay, solving for x, I subtract this 4x over to the left side. I would be left with x equals 12. For number 3, I am going to try to rewrite both of these as a power of 10. So this would be 10 to the 4x plus 1. And the right side is going to be 10 squared, right? Because 100 is 10 squared to the x minus 2 power. The base of 10 is equal, so I need to make the exponent part equal. So when I distribute here, I will get 10x minus 4. When I work to solve for x, I'm going to move my x's to the left side, so I'll have 2x left over here. I'm going to subtract this 1 over to the right side, so I have 2x equals negative 5. Last step would be to divide out the 2, so I would end up with negative 5 halves. Lastly, number 4, 5 to the 2x. Again, I'm going to try to rewrite this 125 as a power of 5. So that would be 5 to the third. And then when I rewrite this, I try to put some parentheses around this original exponent to remind me to distribute. So I'm going to end up with 2x equals 3x minus 15. So I'm going to work to isolate x. I'm going to end up with x equals 15. Not negative 15, but just 15. Common mistake would be to forget about those negatives, or to make both sides, leave it as both sides being negative, right? When we finish a problem, we have to have x but completely by itself. So that's the first set of problems. Over here on the next two, 5 and 6, looking at exponential growth and decay. So the best place to start with these is to enter our equation into our calculator. So I'm going to hit the y equals button, and I'm going to type it in just as we see, 2.5 to the x power. And I can hit graph to get an idea of what my data is going to look like. So I can answer the growth and decay question right now, right? I see that this is exponential growth, right? So this is growth. So in order to graph this, need to go to the table to get some data. Right, so I'm looking for data that'll fit on the graph. So I have, I see that the data comes in right here. It starts to increase a little bit. And then at 0, 1, and then 2, or 1, 2.5, and then 2, 6.25. Right, so my data comes in and starts to increase like that. Right, so my domain for all of these exponential functions will be all real numbers, negative infinity to positive infinity. And then the range is based on where the data starts to approach but never touches. So the data goes up to positive infinity, but it does not ever get to 0, right? That would be the asymptote. So y is always greater than 0. So that is how we do domain and range. And then over here for number 6, again, we're going to type in what they give us. So we have e to the negative 0.75x. And as I'm typing that in, I see that negative value up there. And I should be thinking, man, what does that do to my graph? And when I hit graph, I see that it makes it come in from positive infinity, and we see some exponential decay, right? Which makes sense because we have that to a negative exponent there, that base of e. And so my domain is still going to be all reals, all real numbers. And then my range, over here in the graphing screen, we can see how the data comes in and approaches 0. In the table part, we can do the same thing. We see in the table that the data gets close to 0, but in our window it never actually touches. And lots of approximations here with the data. With that natural base E, that's going to give us some tricky data to graph. So we see that the graph comes in from positive infinity and approaches 0. So again, my range is going to be y is greater than 0. For problem 7, we could enter this into the graphing calculator. We could put it into y equals on the graphing calculator. You could calculate it by hand. My suggestion would just be to type in exactly what you see, right? I have negative 8 times 2 to the x power, but they tell us in the problem that they want the y-intercept. And y-intercept right here tells me I am looking for the point 0 comma something, right? Whatever that intercept is. So they're telling me that the x value is 0, and they want to know what the y value of that intercept is, right? What is the y-intercept of the graph in the xy plane? And we see in our multiple choices here how they all start with 0 comma, right? So y-intercept is when x is 0, and then the plus 22 from the end of our original function. So I can hit enter, and I see that the answer is 14. So that would be answer choice A. Similar problem in number 8. I could enter that into the calculator. 2 times 3 to the x power, and they tell us that we want to find f of 2, so that means our x value is 2. We can solve it in the calculator. This one would also be pretty simple to solve just on paper, or maybe even in your head, right? 3 squared is 9, and 9 times 2 is 18. Notice that they put the 9 from 3 squared in there. They also put 12. Common mistake would be to make 3 squared. People do 3 times 2 and get 6. 6 times 2 is 12. That's also one of the answer choices. So I have to make sure we are paying attention and using exponents properly. Compound interest problem. We're going to put a lot into the calculator here. Start off by filling in our equation. Our amount is equal to principal, that initial deposit, $1,600, 1 plus our interest rate, which is 1.5%. We need to turn that into a decimal. And then the n value is how often it is compounded. They tell us here it's compounded daily, so that's 365. And then our exponent is n, which is the 365 again, times t, which would be the 7 years. Right, so that's the problem we are trying to solve. This gets a little tricky to enter into the TI-83. We're going to start order of operations, says we start in the parentheses, and we will do that division right there first. So that is where I'm going to start on the calculator, 0.015. That interest rate divided by 365. Right, so it gives it to me in some scientific notation there. I'm just going to keep working the problem. So I'm going to hit the +1. So that is my value that should be inside the parentheses. Next in order of operations, I'm going to do the exponent part. So I need to make sure that I put parentheses around my exponent, 365 times 7. And so that is what needs multiplied by that initial amount, right? So after 7 years in this account, I have $1,777.13. Always good to stop here and think, does this answer make sense? You know, they have a fairly small interest rate and a fairly small amount of time. Increasing my by $177 seems logical. If you get, you know, thousands of dollars or even millions of dollars, obviously that doesn't make much sense, and you want to make sure that you have entered things properly. Some exponent properties here. All of our exponent properties are the same even when dealing with natural base e. So we have e to the 6th times e to the 5th. We are going to take and we are going to add those exponents in that situation. That gives me e to the 11th. Here in number 4, 20e to the 8th over 5e to the 3rd. Well, I'm going to divide the 20 and 5 and give me 4. And then e to the 8th over e to the 3rd. I am going to subtract those exponents. So my answer there would be 4e to the 5th. For number 12, I am going to use the power property. So this 2 out here, that squaring gets applied to everything inside the parentheses. So it's going to end up, and I'm going to show you a step that you probably won't write down. So I squared the 4, and I need to square the e to the 2x. So 4 squared is 16, and in this case we multiply the exponent, so this becomes e to the 4x. Okay, so we multiply the 2x by 2. Chances are on your test you're going to just do that in your head and not write down that first step that I wrote down. For 13, we take the square root of everything inside. So square root of 16 is 4. I've done that. And then since this is a square root, there's a 2 implied right there. So we are going to divide the exponents all by 2. So e to the 4x becomes e to the 2x. So that is the exponent properties part of the quiz. And then we're going to close out with this problem about compound interest. A couple of questions. Which count has a greater principal? Well, principal is the initial amount. So friend starts off with 4,200. Your principal in the equation would be right here, the 3,800. So friend has more, has a greater principal, right? His initial deposit is $4,200. Part B is which person has a greater account balance after 15 years, right? So we go to the graph, and it looks like friend has a balance at 15 years at about $7,000. We can't see exactly in the graph. But for your account, we're going to use the equation, right? A equals 3,800 times E. And again, E is used when we have that constantly compounding interest, 0.05 times the time of 15. So we're going to calculator this up. I'm going to type in 3,800. Let's clear out all that other stuff for a moment. 3,800 times e to the 0.05 times 15 power. Right? The 0.05 is that interest rate, and times 15 years. So after 15 years, our account is worth $8,044.60. So you have a greater account balance than friend has after 15 years. So that wraps up the review for the Chapter 6 quiz, the first quiz over Chapter 6.